9.6a, we're going to go cover inverse trigonomic functions. So we learned about sine, cosine, and tangent. So now today we're going to learn about the inverse of sine, cosine, and tangent. So first let's start with a quick review. Write the sign of the f in the equation. So remember our phrase that we want to remind ourselves to use, so katoa. The first one is sine, so I'm going to write that over here. This is so. Cosine is ka. And then tangent is toa. So katoa. And so is opposite over hypotenuse. So our sine of f is opposite, which is, okay, so our angle F is here. Our opposite is ED, the side ED, and our hypotenuse is the longest side, which is FE. This gives us 5/13. Ka for cosine is adjacent. So cosine of f is our adjacent. Our adjacent is right next to it. So that's FD. FD. And our hypotenuse is FE. FD is 12. FE is 13. TOA, that's our tangent and of f. TOA opposite over adjacent, opposite is ED. Adjacent is FE. That gives us 5/12. Angle F is an acute angle. That's the type of angle F is. It's smaller because we have right angle triangle. All the other angles are going to be acute angle. So far, to find a missing side, we know we have to set up trig function and solve using algebra. In order to solve by using sine, cosine, or tangent. But what about angles? We can use trigonomic functions too, but they have to be inverse. So the inverse allows us to use the sides. Basically, it kind of undoes it. Uses the sides to find the angle. So the inverse functions. Remember, an inverse kind of means undo or kind of flip upside down. So we're flipping that function not kind of upside down. Yeah, upside down. These are on the calculators, and I will show you how to punch the inverse. You just press second and the exact same thing. So second sine will give you the inverse of sine. So the inverse of sine is this button right here. Keyword, the -1. And the inverse of cosine is with a -1. Remember, so katoa, sine is so, cosine is ka, and tangent is toa. And the inverse of tangent is the tangent to the -1. So to find a missing angle, we need to know two side lengths and we will use an inverse trig function to find the angle. So let's try it out. So here it says tangent of A is 3.5. So then to find the inverse, we are technically doing the inverse of tangent of A equals the inverse of 3.5. So this is what we're doing. This cancels out tangent, and we're left with A. And we punch this into the calculator. We punch the inverse of 3.5. This tells me A is 74.05 degrees. Remember degrees. Our angles are in degrees. Same thing here. We want to take the inverse of each thing. This cancels out my sine, so we have A equals the inverse sine of 0.55. We punch that into our calculator. We should get A equals 33.37 degrees. Number 3, once again, we got cosine, so we want the inverse of cosine of A equals the inverse of 0.45. This cancels out my cosine, so then A equals the inverse cosine of 0.45. We punch that into our calculator. A should be 63.26 degrees. Okay. What if we want to know the angle, but we do not have what it is equal to? So first, we want to start out by what we want. We want to set it up to write the correct trig function. So we don't know exactly what we want. So we start out with what angle you want and label from the angle you want opposite, adjacent, hypotenuse, OAH. Choose the correct functions from your letters from your labels of either SO, CA, or TOA. Substitute, then we replace the known side lengths. So let's see here. So then with that, we solve to use the inverse functions to undo the function. So let's just try out with this. Okay, so we want the trig function for A. I'm going to mark A, just so I know that is the angle I'm using. So then this is my O for A, and this is my A as adjacent, and this is my H. I want this, so I want to know what I have. I have an O, because that's a number, and I have an A. So I want the tangent, so my tangent because of TOA. So here, my tangent is going to be the opposite, which is 12 over 6. Now we can solve for this. So now we want to take the inverse and it should solve for it. So this gives us A. This cancels out tangent. The inverse tangent of 12 over 6. We punch that into the calculator. A should equal 63.43. Okay. Next one, we want C. All right, I'm going to make C a different color just so this helps me. C is here. I'm going to cross these out for now. Opposite of C is this. This is my adjacent to C, and this is going to be H. That's going to be H. And I have my adjacent and my opposite. So that just means I'm also going to be using tangent. So let's see here. Tangent of C is opposite over adjacent. So it's 6 over 12. So now I'm just going to solve. So like inverse tangent of C should equal the inverse tangent of 6 over 12. This cancels out my tangent. So C should equal inverse tangent of 6 over 12. Punch that into the calculator. C kind of equals 26.57 degrees. I'm going to mark box that in and box that in. So that's how we know. We got to label them and then solve them. Okay, G. I'm going to mark G. Opposite, the adjacent of G. Oh, wait. This is my hypotenuse down here because my hypotenuse, remember, is opposite from the 90 degrees. So this is my opposite. This is my adjacent. I have all three. I can use whatever I want to solve for G. So I'm going to use sine just because I have opposite over hypotenuse. I have all three. It doesn't matter what I use, but I'm just going to use sine. So I'm going to use so. So my setup is sine of G must equal opposite over hypotenuse, which is 72 over 97. So then solve. Inverse sine of G is the inverse sine of 72 over 97. These cancel out. G should equal the inverse sine of 72 over 97. If I punch that into the calculator, G should kind of equal 47.92. Let's do the same thing, but now for F. I'm going to mark F. I'm going to cross these out. My hypotenuse stays the same. It's always going to be hypotenuse. But this is now going to be my opposite, and this is now going to be my adjacent. For F, I'm going to use sine again, just because. So sine of F is now 65 over 97. So when I just take the inverse sine to solve, inverse sine of 65 over 97, this cancels out. So then F equals the inverse sine of 65 over 97. Punch that into the calculator. This gives me about 42.08 degrees. So that's the answer for F, and this is the answer for G. One last example here. So let's try a trig function for D. So D is here. This is the opposite. This is my adjacent then, and this is my hypotenuse. So D, I have my opposite and adjacent. So I'm going to be using TOA, or tangent. So tangent of D should equal 21 over 20. So if I do the inverse tangent of D, should equal the inverse tangent of 21 over 20. This cancels out. D equals the inverse tangent of 21 over 20. Punch that into the calculator. I get about 41.40 degrees. Next one, I want E. I'm going to mark E, going to cross. Oh, I can cross everything out. This is my hypotenuse. This is now my adjacent. And this is now my opposite. So for E, I have my opposite and adjacent. So it's TOA. So tangent of E should equal 20 over 21. So then the inverse tangent of my tangent of E is equal to the inverse tangent of 20 over 21. So E equals the inverse tangent of 20 over 21. Punch that into my calculator. I should get about 43.60 degrees. And that's how you find these.